So the idea behind the co-developer lightning talks is actually something that came from the Shark Bites. For those of you who don't know that, Shark Bites is a SharkFest invention of sorts where people present 15 minutes on a topic of their choice, and it can be a wide variety of topics ranging from video game hacking to climbing to personal views. So it's quite an interesting choice, and we thought we make developer lightning talks and trying to establish them. We started in Estoril, where us co-developers present features, ideas, things that happening around Wireshark source code, or which we find particularly interesting, or which is a cool feature to do, or whatever. So we started in Estoril, and we're continuing onwards and hopefully improving the content as well as the presentation and what is interesting for you. If you have any questions, this is an open session. Shout out, ask us questions. You can interrupt us at any time you want, and we're gonna just start. So, as I said, we're talking about things we like, and just ask us if you have any questions at all. And to start, our fearsome leader will talk a little bit about the real fearful stuff of navigating Wireshark with JIT and CMake.
As I mentioned in the keynote, Wireshark has 2.7 million lines of code, and so trying to find any sort of bit of code that you're looking for is usually a big needle in haystack exercise. As a bit of history, when the project first started out, the very first release that I made 20 years ago had just these files, and that was about 2,300 lines of code, and it was really easy to search, and everything was in the same directory. But as you grow and expand over time, you kind of split everything off into subdirectories, and sometimes those directories get really deep, and that's kind of what happened with us. To get the Wireshark sources, you can download a source tarball, but we really strongly recommend that you use Git, and this is the standard URL you get used to fetch the Wireshark source code. You can also fetch from a mirror that we have on GitHub, and I don't know if anybody does that or not, but I think most people just use our source code repository URL. Once you've checked out the source code, there are a bunch of things in the top level directory, a whole bunch of files and directories. The main ones that you should really be paying attention to are EPAN, which is where all the dissectors live in the dissection engine. Dissectors live down under EPAN dissectors, except for plugins, which live in plugins. Looks like I need to update this because the GTK no longer really applies. But under the UI directory, there are both directories for the Qt UI and the command line UI. We treat the command line interface as a separate UI, conceptually at least, and kind of in reality as well. Wiretap has all of our file parsers, and WSUtil has a bunch of utility routines that kind of don't fit anywhere else. That's kind of just where they ended up. And Image has all the icons and logos and various things like that. And we have two documentation directory. Docs has all the man pages, and DocBook has the DocBook documentation, like the user's guide and developer's guide. You'll notice that EPAN maybe is a funny directory name, and Wiretap is a funny directory name for something that reads files. And the reason for those two are that when we very first started out, EPAN stood for Ethereal Protocol Analyzer. And we changed the name of the project, but we still have this directory name. We've never renamed it. So now I think it stands for Enhanced Packet Analyzer. We just kind of retroactively went in and said, okay, that's no longer Ethereal. Wiretap is named that way because really early on in the project, when we first started out, libpcap was unmaintained. You could download it and compile it, but nobody was updating the source code. and we had a valid concern that that project was dead. Luckily, it's not. Luckily, some people have picked that up, and they maintain it to this day. But we were thinking that we would have to write our own packet capture code within Ethereum, and that's why it's called Wiretap. So now we have this directory that's also misnamed. But I'm not too upset about it. If you download Wireshark for Windows and you want to build Wireshark on Windows, you have to set up a whole nother directory for libraries. And you just basically tell Wireshark where you want to put this library, and it'll download, as part of its setup, it'll download all the external Windows libraries and place them there. Inside each source code file, we have three main components. We have a section at the top that has boilerplate, which lists what the file does and the license. Usually, prior to, I don't know, the last couple of months, that section used to be pretty big because we had the full and complete, well, we didn't have the complete GTL, but we had this huge blurb that said this is, released under the GPL and so on, and maybe had some authors' names and things like that. We've abbreviated that as kind of a small project recently, so that part of the file is smaller. And then you have the actual section of code that does what you want it to do, and at the very end we have a little section that is commented out that has little commands for various text editors for setting up things like tabs and indentation and so on. And how far lines go over when you indent and whether you use either spaces or tabs. Something that I do quite often is search through the code. Like when I'm making a release and there's a bug with a particular protocol detector, I want to go dig through and find out what exactly that bug took care of. And so I find myself looking for proto-register protocol, which is the routine that sets up a protocol. And so when I make up the release notes, I want to get the protocol name right. I'm old and I can't remember what all the exact names of these protocols. So I search for that to find the official protocol, at least within Wireshark, the official protocol name, and that's where that usually is. Inside Wireshark, all the display filter fields are set up using header field entries, and so I will look for HF underscore blah 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 to find out a particular header field and where that's defined. And if I'm looking for a particular bit of functionality, I can kind of leapfrog off of there and find out where that gets set up.
Do you have any tips about finding things in Glue?
You mean within Qt?
Yeah.
Yeah, it's effectively the same. And thank you for segueing me into the next slide, which is about searching. I use git grep a lot. That's kind of my go-to tool, because I know that since I'm checking stuff out using git, that's going to be present on whatever machine I'm using. And there are a lot of different things that you can pass to git grep, but in this case, in this example, if I do a git grep -l, which lists the files that it matches for _rtp_info, I can get a list of those files. From the bash shell, I can say git grep -l syntax state uiqt. It'll list all the files that have the word syntax state in them, and then feed that into Qt Creator. QTC is, I don't know if that's standard, it may just be something I set up on my machine, but that opens Qt Creator with those files. And I can do the same thing down here. These are just mostly the same examples. When I did this talk in Esteril, I talked about how I love git grep and use it all the time, and Dario, I think, came back and said, well, I think he uses ACK or AG, which he uses a different search program, and he really likes it. So along with git grep and GNU grep, there are all these other search programs that you can use to find stuff on your file system. And people were really fond of them and use them. If you want to find out what they do, there's a nice comparison page at this URL. So if you do use the command line a lot, like I do, this may be beneficial to you because you can go, maybe find stuff on your system a lot more quickly. I also use git log a lot. Just when I make a release, I have to go digging through the history of the commits just to find out what happened and what's behind a particular feature that may be listed in the release notes, or I may need to figure out what a change was so that I can add a description to the release notes. Git log is really helpful for that. Yesterday, at the keynote, Roland was talking about the fact that on Mac OS, recent versions will stick in a menu item that we didn't really want there. And when the user reported that to us, we both sat there digging through Git log to find out where Wireshark was adding this menu item, and we were having trouble. We're tearing, or at least I was tearing my hair out trying to find out what was happening. And as it turns out, it wasn't Wireshark that was adding this; it was Mac OS. So yesterday was one of the first times in a long time that I didn't find anything using git log. But git log has a lot of cool features. This is just a really simple example. If you say git log author equals Gerald, since equals, this is wrong, it should be 8 days and not 8D, but that'll show you what you did for the last week, which when I send my weekly report into my boss, I do that really quickly and see what it actually, code changes I actually made, because a lot of times I forget. On the Mac, I also use Time Machine occasionally. So I'll go back and look through my repository, and if I made any temporary files that weren't actually in Git, I can find those using Time Machine. Wireshark is 20 years old, and a lot of protocol specifications are that old or even older. However, the websites that host protocol specifications are usually around for maybe between 6 months and 5 years. At least that's the impression that I get. So within the Wireshark source code, we have a bunch of URLs to a particular protocol that describes what the code's doing, and then after some time, that URL goes away, and so you get to wonder if the Wireshark source code is then the reference implementation, or at least some sort of reference for that protocol. So one of the things that I've actually done recently is, I'll look at a protocol detector and try to go to the URL specification for that protocol and notice that it's gone, so I then have to dig through the Wayback Machine and replace that URL. So the Wayback Machine is actually useful for that. And I think that's all I had. Any questions or comments?
What's the most annoying thing?
Knowing
what you know now, it's been 20 years, what's the one thing you would go back and change, knowing?
I'm not sure. There's a whole vast array of annoying things with doing development on Windows, especially open source development on Windows. Everything from packaging to just getting things to compile and things like that. And it's not necessarily Microsoft's fault. It's a lot of it has to do with the fact that the open source community is just pathologically blind to Windows. And so when they put out these libraries, Windows support is the last thing they think of. And that's part of it. Another part of it is that up until recently, there just hasn't been a good packaging system for Windows. So that's something that we've had to create ourselves. And when I was talking about the Windows library directory, that's part of that. We have this whole infrastructure that stores Windows libraries that we've compiled and built, and then they get downloaded and placed in that library. And we set up versioning and things like that.
So for the third part, we have a little talk that originally Richard Sharp gave at Europe, and he, the whole idea is to trigger ideas, trigger things that we think are cool. And one of the things that are cool but often overlooked are expert fields. Now, expert fields don't look like much. If you write your own dissector, and you know all the fields there are, and basically fill them all out. But there is a nice little feature Gerald mentioned during the keynote, which is the fuzz testing. And fuzz testing really is, we throw a lot of garbage at each dissector generated by original fields and see what goes wrong. And most of the time the people just accept that something goes wrong and break or just return. But that's not what's happening in a real world scenario. Traces get cut off, packets get cut off. And so you often end up with a trace which is incomplete, and that's where expert info really comes in, because then you can add this information to your dissector and show your user, hey, look, here did something go wrong, and even provide him with an analysis of what he can do better to improve on the situation. So what is actually an expert info? Well, an expert info is nothing else than a normal header field. It's the same thing like we use for the HF fields. So it's just called a little bit different with EI. And you can add an expert add info exactly the same way you can add a header field. It gets added at the current position, so it relies exactly underneath where you want it to add, underneath that tree item or underneath a specific item. And you can even add it. For instance, in this case, it's an expert info for an IEEE 802.11 tag length, and it says, okay, it must be at least 2 octets long. So apparently during the sections it didn't receive 2 octets, it just received 1, for instance. And this is actually really helpful, because then a user, when he goes through the protocol and for a specific application, then he sees what went wrong, what can he do better, what can he achieve at that point, and what can he improve on. How do you use them? Well, there are actually a bunch of different informations you have to add. So for instance, you have to add a description for it, which means they're searchable via display filter. They even show up when they're tagged correctly as malformed and error, for instance, in the expert info. Expert info is an analysis tool where there's a lot of information being displayed about all the expert infos in this trace file, and you can really fast look up what went wrong, what were the problems, what can be fixed. And you have some additional information, some additional text there, which you can then search for. And to be really nice to users, you can even use variable arguments. So for instance, you have here an unexpected IE, and you can tell him the tag number and say, okay, I didn't expect something else, but this is the tag I got, for instance. It depends strongly on the protocol you're using. So for instance, with my protocols, I usually write here, I have the different length, for the CSEs do not match, something like that, or the CSEs, I have 2 frames that get transported and tell them CSE for the second frame didn't match the one from the first frame, something like that. This is actually background info you have about your own dissection, but doesn't really reflect on fields. So if, let's say for TCP, you know, okay, the fields have to behave in a certain way, and suddenly you get something else, you can always throw an error. You can always throw an expert info. But it's even more intelligent to put here a message that tells the user in a small sentence what you actually were expecting. So because this is information that isn't really stored anywhere. It's, as Gerald said, that's written in a subtext on some protocol specification. And for using them, just think of this slide. Try to avoid bailing out. If you create an own dissector, if you create your own protocol, just try to ever avoid bailing out. If you ever have the need of writing return somewhere, or return false, which is always a nice thing, or break, think of, well, maybe if I break here, I need to have an expert info to explain why I break here. It's like documenting your source code, just with a little difference that not the source code is being read, the protocol dissection is being read. And it helps developers when they then go back to the dissector and try to figure out what you wanted to do, but it even more helps the users. So for instance, one of the expert infos that's pretty often seen, not except if you trace with Windows, is the TCP checksum. The TCP checksum is implemented using expert infos, and you get expert infos if the TCP checksum is calculated wrong, or if it's not there, but you wanted to have it there. That's a pretty good example. If you enabled in the protocol dissector that you want to have the TCP checksum calculated, but it's missing. There is no trunk bytes on the TCP stream because Windows removed them from the cache. And so the user knows, okay, I enabled the feature, but because of the protocol dissection and because of how the way the packets got captured, the feature cannot be used. Yeah, well, that's about export info field. The next talk we're going to do is, I think Stephen is going to like that. We implement the file format. Martin. I had to find a title and I didn't know the title before.
I was wondering if that's Peter's thing or
No, that's
mine.
yours.
No, basically, there's just one message I want to get across. It's rather simple to add a new file format to Wireshark. We are receiving a lot of submissions for protocols, however obscure, but we get very little submissions for new file formats. It's easy to do, even if the format is proprietary, undocumented. You can get, like with a protocol, you can get started by just decoding some simple fields. So that gets us to the question, why should anybody do that? It's because you might have interesting data in a file that Wireshark cannot yet read. This is probably not really the case for people into networking, but it's the case for people capturing other data. Like I captured a lot on digital TV, and now I'm looking at stuff going on between a smart card and a smart card reader. So what you usually have, you have a proprietary tool that creates files in a specific format, and you have to use the software that comes with the capturing hardware to read and analyze the thing. And this is usually nowhere near as convenient as Wireshark, and it's helpful if you're able to convert those things or make the files readable by Wireshark. The whole point I'm trying to make is that this is something that is doable with reasonable effort. So basically what you have to do, the indentation got a bit messed up, so you have to provide three routines. The first one is to detect, is that my type of file or not? So most files have some file header or stuff, so they're easy to recognize. Otherwise you have to go through and look at the first bits of data, see that makes sense. You have to provide a routine to read the next packet, so we can go through the file packet by packet and get the information out, and you have to provide a way to have random access when the user jumps to a specific packet. It will take you to an offset and say, give me the next packet from that point. So to make your life simpler, to implement that, things are rather easy if you implement read-only support, which in the case I just outlined is what you want. You want to use the vendor's capture tool that can drive the hardware. You get the file and want to open it in Wireshark and process it. So read-only support is enough. The next thing that I found quite interesting is it's simple if you understand how the basic structure is working to skip over this large sections of the file. It's perfectly okay if for 90% of the content you have no idea what that means. You just, if you have a basic understanding it's made of records and you know how to find the next one, it's okay if there's 10 record types and you only understand 2 of them. You can just remove the rest and display what you know. I mean, that's the same with the protocols. It's no problem if you submit a protocol dissector and you have no idea what most of the fields mean. As long as we don't display wrong information, it's okay if we just say we don't know what that means. Timestamps is something where I found that's a bit more difficult than just getting the data out of an unknown file format. So that will make your result a bit less useful, but as a first step, it's okay to skip the timestamps. So I did that for 2 vendor tools I had to use, and I was quite surprised that it's rather simple to do that, and it's beneficial to be able to read files in Wireshark rather than having to ask everybody else to install a specific tool to look at a capture file. So much on my side.
So I got a question for you. So is this what, like, Gerald, maybe you know, Sysdig is doing, incorporating their tool to be readable as part of PCAP?
Well, what they do is write to PCAP-NG. They just write
They
their
just
own
use
block.
PCAP-NG.
Yeah, they have their own custom block that they write in PCAP-NG process.
This is what I did for the NetScreen reading of NetScreen text output, like 10, 15 years ago. Because NetScreen was able to output packet data with the details as well, but it was only text-based on the console or your CLI session. And there was a script that could convert it, and then you needed text to PCAP to convert that output of the script, and then you could make it PCAP, and then, well, it's quicker to write a file import module. It's pretty straightforward. If you take one that resembles a bit of your protocol, or is a very general one, look at the NetScreen one, it's a very general one, just take that and adjust it to your own needs.
Yeah, what helped me doing the things was to have a text output convert to text in the vendor's tool, so I'd have the binary file and the text output of what the tool says is in there, so you can go and find the blocks and get an idea what the file looks like.
We actually have a file reader for PCAP-NG to show the blocks we use for debugging and implementing the PCAP-NG reader.
Yeah, I was just gonna try and find
Last option of this menu.
last option, right? Yeah.
Oh,
Yeah.
There is a nice the thing is, there are a lot of features in Wireshark which you usually don't see, and one of those is something we kind of forgot about. Well, I have a trace here. This trace in itself is pretty cool because it's a download, an HTTP download, so I can go to see the download stream, I can go follow the conversation somewhere.
Above copy.
Pardon?
Above copy.
Above copy.
Yeah,
follow.
There it is. Follow HTTP stream. And then hopefully get to the good part, which is I need I think it's this one is the last one, right? No, let's go with this one. I can do, this is the get, and I can show packet bytes. No, but
Now you need to be on the response.
Had to filter and HTTP. And
come here. No, it is. Oh, no, sorry. It's already doing that. What we don't see is it's doing it on a second screen. So,
And we want to show the response.
yeah, here it is.
No,
Of course it is.
that's your follow stream. What you want to show is the image, right?
Then do it, yeah. I'm the UI guy and I don't know it.
try the AND HTTP, because currently you see all TCP segments that are related, and this way you can find. Let's see.
There it is. Now you need the, yeah, I think that's.
So in HTTP layer,
yeah, that's what I wanted to do. Thank you.
have you any configuration?
Double click on the window because it's too big for your screen.
Maximize something.
What would you want to do?
And maximize your.
If you double click on there.
Yeah.
Ah, there it is.
Yeah.
That's HTML. We don't want HTML.
At the end. Yeah. Okay.
Remove TCP stream equals 0 and the end.
Yeah. Let's do that.
And there's a JPEG. Just
Yeah, I want the big one.
you don't see the big one.
No, I don't. Well, I do if I do the following.
Short it. Oh.
Oh, he didn't do the size. Sorry.
Content length here.
Well, you guys have time, right?
Well, I'm only flying out on Thursday, so. Everything's going
Well, come on. Is it downwards or upwards? Oh, no, it's. Yeah, I'm gonna take anyone. I don't care. So, this is a graphic picture in there. It's an HTTP transfer of a graphic picture. And one cool thing you can do is this one and show it. There's a college humor picture in there somewhere. I have no clue what. But this is something which a lot of people don't know, that is, you can actually show images here. You can show, of course, you can show back the hex dump or something else. But if it's an image, if it's in the right format, it shows an image. If you want to say just what else is going on in this file, there is underneath view, there is a reload as file format capture, which just reloads the whole thing. I have to switch back to the. That's my Mac.
Did it crash, perhaps?
Yes, it did. Okay, I tried with a different file. It's reloading. And okay, then let's not try it with the development version, try it with 2.4.
It's nice to see that other developers do the same thing I do. I have maybe 6 versions of Wireshark on my machine, and all 6 are very unstable.
So where is it now? There it is. So this is the same captcha I showed you before. Again, there you go. He doesn't want me today. Oh,
Just double click on your.
No, he doesn't want to do full screen.
No, but it doesn't do full screen. It uses the full screen without doing full screen.
This you mean?
No, next to it now, double click. There you go.
The problem is I can't. Oh yeah, I can't do that. So I just reloaded the file. It's underneath a few reload as file format capture, and now I see the same the pkpng stream with the file format in it. So I see the actual blocks within pkpng, and of course, if I go up there, if they go to the block data, he dissects the packet data he's having. So in this case, this is a TCP transmission, which is actually pretty neat, because if you do, for instance, if you have comment blocks in there, he shows you the comment blocks. If you have additional text record blocks, he shows you the text record blocks. And this works for every file we have. It works for pkpng. Take a look at pkpng. You're going to see the blocks pkpng, not pkpng, png for instance, or JPEG. So you're going to see the blocks. You can open a movie file. You're going to see the movie frames. So this is actually quite neat. And all you have to do, if it's not crashing this time, is switch back and go back and watch. So I'll stop that before we kill anything else. And doing something else cool.
Decrypting GLS.
Decrypting GLS.
For this demo, I'm just going to show you how to decrypt the GLS while using Windows VM. So usually when you start Firefox and you visit a website like, I don't know, Wireshark, and it's encrypted. Ooh. You won't be able to see. So I'm trying to locate the HP, like the IP address for Wireshark, so I can fill them on it. So it's
If you enable neighboring solution, you can type in IP address equals Wireshark.
That's a good idea. Network address.
So as long as it's resolved, you can just use asset tags instead.
Equals www.wireshark.org.
Oh yeah.
Without the plus.
And need to. Oh. Well, too bad. Oh, okay. That works. Alright, so currently it's encrypted and I can't see anything. I know there should be HTTP inside, but there are no results. That's because it's like encrypted. So how can we actually start reading it? We somehow need a way to decrypt it. So we can do that by setting a special environment variable. So for this works both for Chrome and for Firefox. In Firefox, well, for both browsers, you can set the environment variable SLKeylog file. I point to the file right here, and then I start Firefox or I start Chrome, whatever works. Well, whatever program you're using. So if I start this again, we're in the PowerShell. I start Firefox. Oh, by the way, note that I pointed to some file on my desktop called keys.txt, and on the desktop I indeed have file keys.txt that was just created when I started this a script that starts Firefox. Now, if I visit Wireshark again, website, now I should be able to actually decrypt to see the traffic in Wireshark. But before doing that, before I can do that, I have to configure the keys that were just written. So I go to preferences.
You're on TCP, not GLS.
All right. Let's filter for SL as well. Okay, I right click on the SL layer and select pre-master keylog file. Here I point to the keys.txt file which I just wrote. Let's save it. Okay. Now, Now if I search for HTTP packet, I will actually find it. In theory.
And it's loading the file.
I think there were some out of order packets. And we restart capture.
Are you close your browser?
That was a PCAP that you did earlier?
It was live capture. But okay. I can also show a capture I recorded before.
Do a capture and then stop it and then reload, because often there's a timing is a little bit off, so it has the key. The key is not there in time. So
yeah, that could work as well. Let's see. Start capture. Let's get rid of it. Perhaps it was cached.
Yeah.
Alright, there goes. Second time a charm. Too bad. Well, let's see. Okay, HTTP and SSL. So here I have my SL layer and it's decrypted as HTTP. So yeah, that's how you can set up decryption with Wireshark. In this case I used Firefox for Chrome. You can either set this environment variable or use the --SLKeylog file option.
Is the --SLKeylog file option also in Firefox?
No, it is specific to Chrome.
Okay.
Yeah, for Chrome both this environment variable worked and this option.
Okay.
Do note that whenever you set this environment variable or this option, you have to actually restart Firefox or Chrome. Otherwise it won't pick up the changes and your key file will not be written. So let's see. Let me close this and delete this. Well, Wireshark is using it. Yeah. So if I first start Chrome normally and run this script that set the variable. Oh, in this case it worked. This is probably the script that's... Yes, this is the script that sets the option. Okay, so apparently if you set the option it works, but if you set the environment variable it won't work. So, any question about this? Alright, that was...
About this packet data extraction. Whenever you're writing in this sector or whenever you're doing development stuff on Wireshark, you need data to work on, right? You need packet data. And where do you get the data from? You have your own protocol analyzer, so you use Wireshark to get them from the network. But you can also do stuff with the packets. So first you need to get them, then you can edit them, and then you can go build your dissector or do other stuff like build escape rooms with it. Usually we don't have a packet. So where do we get the packets? Well, search online for packets for a certain protocol. I tried for certain protocols and it's pretty difficult. I've got my own collection, but it's not indexed, so basically you're out of luck. You can capture real-life traffic if you have something that generates those packets, of course. Then you can just capture them and use those. Or you can build a test setup with real systems or VM systems that generate those kind of packets. Or you use a packet generator and it creates live traffic. But you can also emulate traffic by saving packets. Let's see, packet generation software, okay. Well, I didn't know what I want. This slide from last year, I'm not sure what I wanted to say with the last remark. What if you don't like the packets? If the packets are not the ones that you need for your dissection or for your dissection writing, then you can edit the packets. There's of course tools like TraceLanger from Jasper that can edit stuff. Bitwist, the old days, is not maintained anymore, and TCP Replay can do that. But those are mainly doing stuff on the higher layers. If you want to edit stuff at the lower layer to test certain corner cases for your dissector, you basically use hex editors or a packet editor like Codosoft or WireEdit. I think the last time I used WireEdit, which is quite nice. Wireshark in version 1 had a packet editor. I think it's stripped out now completely, which is a shame because it was pretty useful.
I have a question about that. Is that planned in version 3 that it's coming in again?
Who took it out? Well, it wasn't converted from GTK to Qt.
Yeah, that's the thing. It just wasn't ported over.
Yeah. So, yeah.
There's no plans to make it. If someone wants to make it, they're very welcome.
Yeah.
We will accept the patch with it.
Yeah, I use it. Yeah, I use it very often. Like
Yeah.
I was in the same boat.
So who used the packet editor in Wireshark 1?
I had to move to WireEdit.
Yeah.
Yes.
Yeah.
I
Well,
actually use text to PCAP to generate just if you need single packet or something. It's fine.
yeah, but that's like a bore because then you need to export a packet to text, change the text, then you can just use WireEdit or something. That's easier. But it's nice to be able to do it from Wireshark. Like, oh, if I change this bit, what happens to the
I
dissection?
understand, but the code is not there and no one is working on it.
Yeah. So okay.
May I ask what's the use case?
When you're writing a dissector,
No, I get the dissector one.
Yeah.
What use case
The
again?
requirement on me to attend here was to autonomize my packets. So I couldn't have any private data. And my data is mostly SCTP. So Trace Wrangler doesn't do anything with anything other than UDP and TCP.
but in Wireshark there wasn't a writing feature. It didn't write it back to a file, so you can show it in your screen, but you can't export it to file, right?
Sorry, what?
If you use the packet editor in Wireshark, it just edits the packet in memory, but it doesn't save it back to file.
I remember that I could go and save.
Yeah, it did?
Yes.
Oh, okay. Well, last time I tried it didn't, so.
It's useful when you see, you flip one bit here, you see what's happening here.
Yeah.
For fuse testing and something
Yeah.
like that. You
Yeah.
have firewalls and load balancer.
Yeah.
You see what's going on when you flip different bits here.
So we were using it for replay.
Yes,
Yeah.
replay and
Yeah. There is a use case. Yeah, I think there is a use case, but there's at the moment no one wanting to port it from GTK to Qt. Might be a nice product to start me working on Qt again, or to have me starting on Qt. I'll have a look at it. But
and there's already a back request or enhancement request open for that, but I think nobody will do it right now. Yeah?
there is an enhancement request on the website for it.
The back database for that, the package is already.
Okay, I'll have a look, and perhaps I'll do it, and otherwise, well, we'll see. Back to editing lower layers. You can also use Scapy. Scapy is a Python library that can read packets, and you can mingle with anything in it, and then you can write it back. For the escape, sometimes if I need for my Lua presentation last year in Estoril, I had some customer data, and I needed the payload, and it needed to be anonymized. So I wrote a Scapy script that basically dissected the packet and anonymized it and wrote it back to file. So you can use that as well. So if you're generating packets with Scapy, this is the way to do a Threeway handshake. It's a Python script. You import all the library routines from Scapy. There are some variables that you get from the command line. I do a random source port. I get a destination port from the command line as well. I created an IP packet. With the IP packet, I create a TCP packet with a SYN flag set, and I chose an initial sequence number of 1000. The SYNAC packet is, I send one packet. Which packet do I send? The IP/SYN packet. So this is actually the SYN is just a TCP layer. This is my IP layer. And if I send a packet with IP/SYN, it creates an Ethernet layer for itself, adds my IP layer, adds my TCP layer, and it sends out a packet. And the SR means send response 1. So it sends out one packet, and it waits to receive a response packet that matches the session. That is being kept in the SYNAC, so I can read from the SYNAC. What I do here is my sequence will be the acknowledgement number from the SYNAC, because that's the next expected sequence number. Then my acknowledgement number is actually the sequence number plus 1, the phantom byte, and I set the flag with an A, the acknowledgement flag. Of course, the ports need to be set as well, and I send my last act. That's the Threeway handshake, and then you can, of course, you can send a request and you can get a response, etc. One thing you need to be aware of if you do it like this, because it's at a lower layer, it doesn't use the OS level. So your OS will send a reset on the incoming SYNAC. So you need to do a filter on your OS that blocks blocks the outgoing. It needs to block the outgoing reset. So you need, on Linux, you need an IP filter or something like that. When I had a trace file and I needed to add some padding, so this is an example where you read it in a trace file, you edit stuff and you write it back. Again, I'm importing the Scapy routines. Packet is actually read pcap, so it reads my pcap file and it creates a structure with an array with all the packets in it. So I browse through all the packets. For debugging, I can print the length of the packet. I keep the time of the packet because otherwise it will mess up your time. I want to keep the packet times the same. So if the packet length is less than 60, then I need some padding. So I add the padding that's needed. I create a pad. I read the pad length that I need. I create padding, and the pad payload is 0 times the pad length. And then my packet will be the original packet plus the padding. I correct the time to the time that was in the file before, and I write it out to a pcap file, and that's it. It's pretty easy. If you know a little bit of scripting, then this can be done pretty easily. If you want to generate a lot of packets, let's see what I did here. Okay, this is actually part of the code that I use to create the packets for the PCAP challenge. But then, so what I do is I have a random function. I create a skeleton for a packet. So this time I also create the Ethernet header. So I create an Ethernet header, an IP header, and an empty TCP layer. Then I fill the template with a TCP port 80. The source IP is random. The TTL is random. The ID is random. The source port is random. The sequence number is random. And you see that there's different sorts of random functions in Scapy. You can just randomize IP addresses, bytes. Shorts is a 16-bit value, and an integer is a 32-bit value. So these generate all the random values that you need. And let's see. I think I need the second screen for this. I set the timestamp for the beginning of the packets, and now I'm creating 250,000 packets with this template, where with a lot of stuff in it. It's a little more complex, but this way you just run write command and you write a whole file of 250,000 packets. It takes a little while to do it, but it's okay. This is the filter stuff. So that's about creating packets. Any questions about creating or using packets or editing packets? No? Well, then some display filters that are not widely used.
So I got a question.
Yeah.
So, like Scapy and everything, you could write a generic DNS scrubber.
Yeah.
Just replace any host name with random characters of equal length.
Yeah. Pretty easily. If you have a use case, we'll work on it together.
Yeah, because I can't. So the two things that I can't show are DHCP and DNS.
Yeah.
Because I use hex editors to go and anonymize.
Yeah.
You know, but if there's because I saw your script there and I was like, oh, you know what, you can actually find every DNS, find because the name, the length changes, right? But if you just you calculate the length and just
or just dash out
xxx.com.
Yeah, with 1 to a billion access. Yeah. We'll have a session on that.
Okay.
So for some interesting display filters, how much time do we have? And is there anybody after me?
Yeah, there is.
Who is?
Me.
Oh, okay. How much time do you need?
It's Wireshark 3.0.
Okay, then I'll be quick. This one is slicing, so you can, from a field, you can slice off a certain amount of bytes from the first position to a slice of 3 bytes and compare that, so you can do vendor filtering. This one is, okay, I have a field which is like 16 bits or 13 bits in case of the TCP flags, and I'm only interested in the last 3 bits. If either one of those is not 0, then this filter will match. So this basically means give me all the fin, SYN and reset packets, which is quite useful. The other one is give me all the broadcast packets. This one is new in 2.0, 2.2, I don't know. The in operator.
It's 2.2.
Yeah, 2.2 I think also, but at least in 2.2 and upwards it's there. And you just give it a list of ports and it will filter on all these ports, which is quite nice if you do T-Shark, get packets that are interesting, print the stream and then wrap it around with awk to make it a proper filter, and then you can feed that to the second T-Shark. Yeah. The contains operator is case sensitive, so that's already nice, but if you don't know what the case is, you can just use the function lower and then use any field in Wireshark and it converts it to a lower case string, and then you can compare with anything. And this one is the most mind-boggling of all. I think I heard about it because Betty was tweeting about it, and then later she asked me about it, like, this filter, how did it work? And like, okay. It's actually, what it means is you have a packet selected, and then this macro will tell you, okay, replace this with the current value of this field. So that means if I make a button in my a display filter button like TCP stream equals dollar accolade open TCP stream accolade closing what do you call that? Curly brace. Well, between the curly braces. That means if you press the button, you will get the TCP stream that you're on at the moment. You go back, you select another packet, you click on the button, and you get that TCP stream. So it's mainly useful in display filter buttons, but it's very useful because you can select something that's in there. The way this is done is like, okay, I have a packet with an IP address. Give me all ARP packets that were sent from this system. So you can create very nifty display filter buttons.
The second to last item, in 2.6, the matches operator is going to be case insensitive. So instead of saying lower HTTP already contains Blok, you could just do.
Yeah, but matches is using PCRE.
Yeah.
And this is just and that's more work and CPU intensive. The contains is much quicker, so that's why I like the contains better than the matches. So contains should be maybe case insensitive as well, but then again we can do it like this, and then you can make it case insensitive. I'm not sure what the additional CPU power is or CPU load is for the lower function. It's probably not that much.
I don't think so.
No, so that's about it.
IP.source, it can't be IP.addr.
Well, the problem with AD,
But then you want to see it both ways.
I'm not sure what it does with a macro if it's a field that we have to test it.
Yeah, that's not.
You can have any native packet.
Yeah,
it has issues with generated fields.
Yeah.
Which usually the ones with the what the other brackets, not the
Square brackets.
Square brackets. Yeah. Those usually it has problems with.
Yeah.
It doesn't necessarily work on that. And IP address is a generated field.
No.
It's a hidden field.
It's a hidden field.
Yeah. Hidden
So
field.
the problem is that you might have many matches in the packet, isn't it? So you probably get
that's
the
also
first
an
or
issue.
the last one.
So the macro is nice, but it has some limitations.
I need to check what it does in a field that occurs multiple times. I'm not sure what it does. Yeah. All right.
Actually, it works if it's multiple times, but not if it's a multiple hidden field.
Okay.
And address is a hidden field.
Yeah. Okay. Any questions about these filters? Useful?
We still have to find who implemented that because we were scratching our heads. This guy needs a beer or something.
Every developer needs a beer.
Yeah, we operate on beer.
Yeah.
Well,
Which protocol was the beer?
Pardon?
Which protocol was the beer?
It's a full bar.
Full bar.
I joined the project about 2 years ago, and since I joined the project, one of my recurring questions was always, when do we get rid of GTK? I think this was the second to the first question I asked Gerald. That was basically my main motivation to come to the first SharkFest, to convince people to get rid of GTK. Along the way, we found out we had a problem with WinPCAP and NPCAP. Along the way, we found out we had a bunch of other ideas we wanted to implement, and so last November in Estoril, we came to the conclusion, well, we're going to break a lot of stuff, and if we break it properly, because then it's new, and so we create a new version with it. That's the main motivation behind Wireshark 3.0. To soften the blow, there are going to be two long-time stable versions. The first one is 2.4, which exists today. The next one is 2.6, which will be released soon. Soon meaning, I think, next week or so.
Yes.
Yeah.
That's the plan.
And 1.12 will still be supported until 2019.
Not by us. It'll
Not
be
by us.
Well, one of our developers works with the Debian project, and he maintains a long-term support branch for Debian. So it is supported, but just
it's supported somewhat.
Yeah.
So there will be versions around with 2.4 and 2.6 for the time being.
Yes.
Including the fix with the macOS tabs.
I did that this morning.
Pardon?
Yeah.
I did the tabs this morning during the keynote. I tweeted it. Check it out.
They're nice tabs, by the way.
Calorie free.
So the move to 3.0 is actually something you guys probably won't see on the front. The first of all is we're going to remove the GTK source code. And that's just so that we have nicer directory structure and cleaner work. The second thing is whenever we add a new feature, we have a lot of time to spend on making it compatible not only with the Qt interface but also with the GTK interface. And we're also using still two build systems. One is called CMake, the other one is called AutoTools. Now, AutoTools is a very reliable build system, but it has a big history. And it's working very well on Linux and nowhere else. So we switched quite a while ago to CMake, which is a meta build system and not really specific to a certain platform, and it's easy to write scripts for and stuff like that. So we're also going to remove all the tools from the build system. You only have to use CMake in the future. The really last remnant where all the tools is in there is because currently we can't build packages for Fedora and Slack. No, that's Slack. SUSE. With CMake properly. Yeah, so we're also introducing new features because we need a reason to tell it to you guys. But the main motivation is really the last line here. It's unbelievably how much time we spend in code cleanliness. So we really hope that it clears up the air for a lot of stuff. What we already did is the master of Wireshark doesn't build anymore with Qt 4 point something. So we removed all the compatibility layers to Qt 4.8, which actually prevents it to build from quite a bunch of SUSE and Red Hat distributions. Yeah. So the way we're going to do it, and this is one of the big great things about the project, is we're only going to do it if we know where we're going. We're not going to do it just for the fun of it and just for the heck of it. So we're doing it very properly, very cleanly, and also the last one really is a should with a very nice ring to it. It should not lead. We're going to change UI. And when you open up, once the dockable windows are implemented, when you open up Wireshark, it will look exactly the same as it does today at the first glance. That's the goal we're aiming for with nearly all of the stuff. As I said, there are some other things we're going to change. WinPCAP is going to be moved to NPCAP, pending some last-minute negotiations, but it looks good right now. We're going to set some higher versions of the libraries. Qt will be recommended to 5.2. glib will be 2.31, I think, or 3.8. I forgot. Something.
I don't remember.
We're going to see which version of libpcap we're using, and somebody hopefully takes the task, and I'm looking in Peter's direction, to move from Lua 5.2 to 5.3. If we get around to it.
There was some problem with that, with the big man.
Yeah, there's quite a few problems with that. Other things which already are coming in 2.6 partly is, for instance, coloring rules are moved to a new file system, so we can easily edit color rules in the future, which you couldn't in the past. It's a simple text format, you can easily do it. And something we aiming for, but are not there yet, but we want for 3.0, is that we have a local searchable web-based help system for all of Wireshark. I think we kind of forgot after H2RL, or...
I looked at that. It's depending on what browsers to do the right thing and do them in the future is probably not a safe bet. So
well,
we'll figure something out.
We'll figure something out, yeah. UI-wise, you're going to see big changes, and one of the biggest change looks like that. So this is going to be one of the things Wireshark will be able to do with 3.0. This is a screenshot from a development build where it luckily didn't crash. It's crashing a lot right now, so I can't show it to you. But it's pretty much, you have the bucket list in the background, and you have the byte view and the project separated as separate windows. Can move them around, can arrange them freely, and if you close Wireshark and open it up again, it keeps the state you had it closed with. which is pretty neat, and it allows you to utilize your desktop space better. So if you have a second screen, you can move the byte view to your second screen if you want to. You can move the product read to your second screen.
And you can justify having a second or third or fourth screen.
Yeah.
Due to your bus.
Once you go ultra wide, there's no going back to multiple monitors.
Well, but then you make it really ultra wide.
Yeah.
One of the things we're going to also add is we're going to see how many of our dialogues we convert to dockable filters. So in the future, it might be possible to have the packet list, and instead of the byte field, you have the protocol hierarchy in some way or form. Or you have the TCP string, you have some other sequence window, you have whatever you want. The comment section, for instance, for each, a comment editor for each packet. Something like that. So we're really moving away from a single tier system, which we have right now, a single view system to a multi-view system. Which doesn't mean that we're going to move away from a single capture file system. We're still going to be a single capture system, a single file entity system, because we can't move data. We're going to have a bunch of new dissectors. And with a bunch of new dissectors, I really mean a bunch of new dissectors. Some noticeable, like Quick, which already is there. Some other things like Bluetooth Mesh, which is really fun. This is actually something Nordic Semiconductors is working on. You have full dissection for Bluetooth 5, for instance. Lower tap, lower WAN, Isobus, there are a lot of things coming. And so, yeah, we're 3 minutes overdue. Badass. When is it expected? This year. We're going to have the release around the time we have SharkFest Europe. But we are not yet sure what kind of release it is. So we're going to release something, but it might either alpha or beta. It might not be the final version. Huh? That's it.